Hey guys, so we're doing our second part of, we are moving on with the last lesson we're going to do before break. The last video lesson, I should say. We're going to have some practice with all this stuff. This is the last video lesson we're going to do before break. Before we get started, I want you to take a minute and do the do now problems. You can pause me, and when you're ready to go over it, just play me again. So for the first problem, it's saying we have circle A that's telling us the center of our circle is A. We have AB is 15 meters long and BC is 36. Now what I want you to realize is that CB is a tangent and AB is a radius. And what happens when a tangent touches a radius? We get a right angle. Now we first want to find the length of A to C. Now, we know we have a right triangle. We know we have 2 out of the 3 sides, so Pythagorean theorem is definitely something we can do. But before we do the Pythagorean theorem, because I don't know about you, but I definitely do not want to do the Pythagorean theorem on 15 and 36, I'm going to go ahead and divide by 3. When we divide by 3, I'm going to get a 5 and a 12, and this ends up being a 5, 12, 13 right triangle. So we divided by 3, now we're going to go back and multiply by 3. So 3 times 13 is 39. So we know A to C is 39 units long. Now we want to find A to D. Well, we know A to D, isn't that a radius starting at the center going to the rim? So the radii of the circle are 15 units long, so AD is 15. And now CD will be 39 minus 15, which is going to be 24 units long. Okay, next one, number 2. So it says we have 2 concentric circles. Remember, concentric means 2 circles with the same center, with the radius of one being 24 and the other 24 and 26 have center P. So I'm going to label that circle P. So we know the smaller circle will have a radius of 24 and the larger one will have a radius of 26. I'm going to put this P up here. So where are we going to draw this radii to help us out? Well, let's keep reading. We have a segment XY is tangent to the inner circle and is a chord of the larger circle. So we know a chord has to touch a circle in 2 locations, but we also know a tangent could only touch a circle in 1 place. So it's tangent to the smaller circle, but a chord of the larger circle. Oh, try this again. There we go. And this segment is called XY. And where it's blue is where it's tangent to the smaller circle. So now we're going to draw on our radii. I'm going to draw on the radius of the smaller circle right to the point of tangency. Why do you think I'm going to do that? Because when a radius touches a tangent, we make right angles. And we know that is 24. We also know when part of a radius touches a chord, it bisects the chord. So we're going to bisect that chord. Now we need to draw in the radius of 26, the radius of the bigger circle. Now I know you can say, well, right there, that's 26, and you're right, but that won't be helpful to us. We always want to make triangles. So I'm going to draw in my radius of 26 right there, so we have a right triangle. Now, we want to find the segment X to Y. Well, I'm first going to find, let's call this W. I'm going to find the length of X to W. We can do the Pythagorean theorem, but doing the Pythagorean theorem on numbers 26 and 24 is large. So I'm going to divide by 2, and we'll get a 12 and a 13. And this is a triple. It's a 5, 12, 13 triple. Let's multiply back by 2. We're going to get 10 for X to W, which means W to Y is also 10. So X to Y is going to be 20 units long. All right, number 3, given BC and CD are tangents. Now remember, if we have 2 tangent segments coming from the same external point, those 2 tangent segments have to be congruent. So we're going to have 4x minus 16 is equal to 2x plus 8. Go ahead and solve this. We're going to subtract 2x on both sides. So we're going to have 2x minus 16 is equal to 8. Then we'll add that 16, so 2x is going to equal 24, and x will equal 12. Now we have our x, now we want to find CD. Well, CD is going to be 2 times 12 plus 8, which is going to be 24 plus 8, which is 32 units long. And the last one, OP is 17, so the segment attaching the two centers is 17. Then it's telling us the radius of circle O is 18 and the radius of circle P is 10. We want to find AB. So this is a common tangent problem. Remember, with the common tangent problems, we had steps that we had to remember. The first step was connect the two centers, which we've done. Next step, draw radii to the common tangent. So I'm going to draw a radius from O to A, and I'm going to draw a radius from P to B. Now remember, when a radius touches a tangent, we end up getting right angles. Now I'm going to label. So we know the radius of circle O is 18. So from A to O is 18. Look how I'm labeling it. And the radius of circle P is 10. So I'll label that as 10. Now our next step. It says from the center of the smaller circle. Which circle is smaller? P is smaller. So from the center of the smaller circle, we're going to draw a line parallel to the common tangent. And what I hope that you realize is we end up getting, or I hope you remember, is we're going to end up getting a right triangle on the bottom, and we are going to get a rectangle on top. So that means, since we have a rectangle on top, these two angles are right angles. And in a rectangle, opposite sides are congruent. So if B to P is 10, then from here to here is 10, which means the part of that triangle is 8. And now looking at the right triangle, we have a triple. 8 something 17. It is an 8, 15, 17. And in the blue rectangle, opposite sides are congruent. So if the bottom is 15, the top is 15, which means AB has to be 15 units long. So that was just a quick recap of all the tangent types of problems that we've been doing. Now let's get into a new type of problem. It's called a walk-around. All right, so our first walk-around is going to be walk-around problems with circles inscribed in a triangle. So there's steps to follow for these walk-arounds. Let's go through, read these steps, and then go through it. Put X's on any corner and label the given information. Walk clockwise halfway around. Walk counterclockwise halfway around. Pick the side that does not have a part labeled as X and write an equation. Part plus part equals whole. Solve. All right. This obviously means nothing to you, but let me show you what I mean. So I want to go through and I want to label what we have, the given information, and make sure you're labeling it the same way I am. A to B is 16 units long. A to C is 8 units long. B to C is 10 units long. Now we're going to go through, we labeled our given information. Now we're going to go through and we're going to pick any side we want and call it X. So I'm going to go to BN and I'm going to call it X. Now, what do I hope that you realize? I hope that you realize, look at those two segments coming from point B. From B to N and B to P. Those are tangent segments. And if we have two tangent segments coming from the same outside point, those two segments have to be congruent. So if B to N is X, then B to P is also X. Now, these are not the only two tangent segments we have. Look at point A. Point A to M and A to N, those are also two tangent segments coming from the same outside point. So those two segments have to be congruent. And there's one more pair of tangent segments. We have C to M and C to P. Those two tangent segments coming from the same outside point have to be congruent. Okay, so we know beta n is x, we know beta p is x. Now, we know A to B is 16 units long, and N to B is X units long. Let's say N to B was not X. Let's say it was 6. Let's say, just pretend, we're going to take that away. But if it were 6 units long, how long would A to N be? Wouldn't you do 16 minus 6 and get 10? Well, that's exactly what we're doing. We know that the whole length is 16, but n to b is not 6, it's x. So how are we going to represent a to n? We're going to say 16 minus x. And then a to m will also be 16 minus x. Now we've gone halfway. Now where am I going to jump to? I'm going to jump around to the other side. I'm going to jump around to the 10. So go halfway, then jump to the other side. Now, B to C is 10, and B to P is x. So remember, we're going to take our whole length and subtract the small one from it. So we're going to say P to C is 10 minus x, which means M to C, because they're congruent, is also 10 minus x. So now, go back to the step. Pick the side that does not have it labeled as x. Have a part of it labeled as x. So A to B has a side labeled as x. B to C has a side labeled as x. So we want to go to A to C because there's no side that's just labeled x. There's obviously an x in it, but it's not just x by itself. So now we're going to pick that side, and A to C is going to be AM plus MC equals the whole length, which is 8. So we're going to set up our equations. 16 minus x plus 10 minus x will equal 8. Now we're going to combine our like terms. So 16 plus 10 is 26. Negative x plus a negative x is a negative 2x equals 8. Let's go ahead and solve. So we're going to subtract 26 on both sides. So now we're going to have a negative 2x is equal to a negative, oh guys, I labeled this wrong. Okay, let's just change it. We'll change this to 16. It's all right. AB was supposed to be 6, but let's just change it to 16 to continue with what we were doing. So now we're going to have 8 minus 26. That's going to be a negative 18. So x will equal a positive 9. So now we want to find the length of A to N. Well, A to N is going to be 16 minus 9, which will be 7. Then we want to find the length of B to P. Well, B to P is just x. We know x is 9. And then we want to find the length of C to M. So C to M is going to be 10 minus x. Well, x is 9, so 10 minus 9, which is 1. All right, let's keep going. Let's do another one. So let's go ahead and label our information. We know we have a bunch of 2 tangent segments, so let's mark those congruent. So we know FE and ED are congruent. We know DC and CB are congruent. We know AB and AF are congruent. We know that A to C is 8. We know that C to E is 10, and that A to E is 12. Now we're going to pick any side we want, and we're going to call it x. So I'll say EF is x, which means ED is x. Now we're going to walk through, we're going to walk around, that's why it's called a walk around, halfway. So we'll go to the left first. So A to F, the whole segment's 12 and the top is x. We're going to do the whole thing minus the top, which is 12 minus x, which means AB is also 12 minus x. Now we've come halfway. Now what do we want to do? We want to jump all the way to the other side, go back to EC. Now e to d is x, so d to c will be 10 minus x, which means b to c will also be 10 minus x. Now, once we've walked around and we filled in every segment, what we want to do is we want to pick the segment that doesn't just have an x in it. So A to E has just an x in it, E to C has just an x in it, but A to C doesn't have an x all alone. So that's the side we want to take. We're going to take that side and we're going to take 12 minus x plus 10 minus x is going to equal the whole segment length, which is 8. So we're going to get 22 minus 2x equals 8. Subtract that 22 on both sides. We're going to get a negative 2x is equal to a negative 14, so x will equal positive 7. So now let's go through and see what we can find out. We want to find the length of A to B. Well, A to B is 12 minus x. Well, we know x is 7, so we're 12 minus 7, which is 5. Now we want B to C. Well, B to C will be 10 minus x, which is 10 minus 7. That is 3. And E to D is just x, which is 7. All right, so that was one type of walk around. Now let's see another type of walk around. Let's turn the page. All right, so now these are walk around problems with 3 tangent circles. What steps do we have to take for this? We're going to put X's on any corner and label the given information. Walk clockwise halfway around, walk counterclockwise the other way around. Pick the side that does not have a part labeled as X and write an equation, and then solve. So it's going to be very similar to the steps we did before. So let's go through and label our given information. So we have segment A to C is 9 units long, B to C is 11 units long, and A to B is 14 units long. Now, what I want you to realize, we have circle O, we have circle B, we have circle C. What do we know about circles? We know in circles, all radii are congruent in that specific circle, right? So the radii from circle A are congruent, the radii from circle B are congruent, and the radii from circle C are congruent. Now, I'm going to pick one of those radii. I'm going to pick one radius, and I'm going to call it X. So I'm going to go through, and I'm going to call radius of circle AX, which means there's X's on both of them since they're congruent. Now we're going to do the same thing we did before. Now, if all of A to B is 14, the long one is 14, and that top segment is X, we're going to write down 14 minus X, which means the radius of circle B is 14 minus X, which means this segment is also 14 minus X. Now we went halfway around. What are we going to do? We're going to jump to the other side now. We know A to C is 9 and the top part is X. So we're going to have the bottom part be the whole thing minus X, which is 9 minus X. So the radius of circle C is 9 minus X, which means this segment is 9 minus X. Now, once we've gone through and labeled everything, we're going to pick the segment that doesn't have an X that's all by itself. It has to have an expression, 2 expressions with X, no X by itself. So that's going to be for us C to B. Now we're going to have an equation, 9 minus X plus 14 minus X will equal the total length, which is 11. Combine our like terms, we're going to get a negative 2X plus 23 equals 11. Subtract 23 on both sides, we're going to get negative 2X is equal to negative 12, so X will equal 6. So we want to find the radius of circle A. Well, the radius of circle A is labeled as X, so that is 6. The radius of circle B, well, the radius of circle B is 14 minus X. X is 6, so we're 14 minus 6, which is 8. And the radius of circle C is going to be 9 minus X, which is 9 minus 6, that is 3. All right, let's do another one. Label what we have. We have A to C is 20, B to C is 18, and A to B is 14. We're going to pick a segment and call it X. Now, it doesn't matter where you start off putting X. So I will put it for circle A over here. And then I'm going to walk around and fill everything in. So the other part of this segment will be 20 minus X. Oops, sorry, I forgot to label my radii congruent, 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 congruent. All right, so now we have the radius of circle C is 20 minus X, which means this is 20 minus X. Now we've gone halfway. Let's jump around. Now we're going to say A to B is 14. The top part is X, so radius of circle B is 14 minus X, which means this radius is 14 minus X. Now we're going to come to the point where we need to make an equation. We're going to pick the side that has the two, that does not just have an X standing alone. So we're going to pick C to B. So we're going to make an equation out of that. So it's 20 minus X plus 14 minus X equals the total segment, which is 18. Combine your like terms. So we're going to have negative 2X plus 34 is equal to 18. Subtract that 34, so we're going to have negative 2X is equal to a negative 16. So X will equal a positive 8. So now let's go through and label what we have. We want circle A. Well, radius of circle A is X. X is 8, so that's our answer. Radius of circle B. Well, radius of circle B is 14 minus X. Well, X is 8, so 14 minus 8 is 6. And the radius of circle C will be this one right here, 20 minus X. 20 minus 8 is 12. All right, let's turn the page and do our last different type of problem, different type of walk around. So this one's going to be a little bit different. Okay, so we're going to put our tick marks and label the congruent segments. We're going to go through and label all our given information and put an X on a specific any corner we want. We're going to walk clockwise until you reach the side you are trying to find. Walk counterclockwise until you reach the side you are trying to find. You'll see what I mean by that. Find the length of the missing side by adding the two labeled segments together. We're not actually making an equation to solve for the missing side. So let me show you what I mean. Let's go ahead. Now we're back to the two tangents, right? Two tangent segments coming from the same point have to be congruent. So we are congruent here, congruent by B, congruent by D, and congruent by C. Now I'm going to pick a point and call it X. So, oh, sorry, not yet. Let's label what we have. We have A to D is 10. We have C to D is 15. We have A to B is 18. Now notice that there's a whole side that doesn't have a length. That's the side we're trying to find the total length, not just part of it, not just an X. So now what we're going to do is what we've done in the other lesson and the other problems. We're going to pick a segment and call it X. I would advise you not to call a segment by BCX. I would call a different segment X. So I'm going to call the segments by AX. So now I'm going to walk clockwise. So if A to B is 18 and the first part of it is X, the second part has to be 18 minus the first part, so it's 18 minus X, which means B to the dot will also be 18 minus X. So we got halfway there. Now let's go back. Now go counterclockwise back to 10. So now A to the dot is X. The whole length from A to D is 10, so D to the dot is going to be 10 minus X, which means D, the other segment coming from D, is also 10 minus X. So now there's nowhere else to really jump. We have to work with segment DC. Now remember, generally saying we're going to do the whole segment 15 minus this first part, but now this first part is no longer X. Now it's 10 minus X. So we need to do some work. So we're going to do 15 minus, now we need parentheses, 10 minus X. Distribute that negative in, and we're going to have 15 minus, oh, what just happened there? There we go. 15 minus 10 plus x, which is going to be 15 minus 10 is 5, 5 plus x. That means from C to the dot is not going to be 15 minus x because it wasn't x, it was 10 minus x. So this is going to be, when we simplify it, 5 plus x, which means the other side of C is 5 plus x. Now, generally, we just make an equation and set it equal to whatever the length is. We're not doing that this time. This time, we're going to pick the side that does not have a total length. So it says find BC. We're going to go to BC. We're going to find BC. And we're not going to make an equation. We're just going to add the two segments of BC together. What do I mean? Well, BC will equal 18 minus x plus 5 plus x. I added those two little parts together. Now, if I combine my like terms, I'm going to get 18 plus 5 is 23. So BC is going to equal 23. And then a negative x and a positive x cancels out. So what's the length of BC? 23 units long. I know this is a little bit different. Let's do one more problem. Then we can call it a day. All right, so what do we have here? We have AB is 10 units long. We have BC is 14 units long. We have C to D is 13 units long. And we have and we want to find AD. Now remember, because of the two tangents, we have the two tangents by D congruent, we have the two tangents by C congruent, we have the two tangents by B congruent, and the two tangents by A congruent. Now I want to pick a side and call it X. It really doesn't matter which segment you choose. I'll choose the part by B. I'll call it X. Like I said, you could put an X anywhere you want. So if B to that dot is X, then the other segment from B is also X. We'll go clockwise. So then C to the dot is 14 minus X, which means the other side of C is 14 minus X. Now let's go back to our original. Let's go back to B. Now let's walk counterclockwise. So we know A to B is 10, so 10 to the dot will be, A to the dot will be 10 minus X, which means the other segment for A is 10 minus X. Now we can't go any further, so now let's go through and go back to the one part that wasn't labeled. What was not labeled? D to the dot. So remember, now we're generally going to do 13 minus that first part, but that first part's not X, so we have to write this out. This is going to be 13 minus parentheses 14 minus X. So let's distribute that negative in. So we're going to have 13 minus 14 plus X. What is this going to be? This is going to be negative 1 plus X, or if you want, X minus 1, however you want to look at it. So we will say D to the dot is negative 1 plus X, which means the other side of D is negative 1 plus X. Now what do? Now we've labeled every single segment. Now what we want to do is we want to go through and find AD. Now we don't find AD by making an equation. We're simply going to simplify the two segments that make AD. So AD will equal 10 minus X plus negative 1 plus X. Negative X and a positive X cancel. You're going to add 10 plus a negative 1, so AD will be 9 units long. And there we go. We are done for the day. No homework, just wanted you to take notes and learn the lesson, and I will assign the homework tomorrow. Have a great day. Bye-bye.